Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Perseverance rovers. So let's dive right into it. Well, first we have to understand this rover exactly itself. It's also called Mars 2020 rover. Now, this puppy is directly an upgrade from Curiosity rover. So NASA built a complete foundation with Curiosity rover, and they are changing the core electronics, but they are not redesigning it from scratch. Basically, it's Curiosity itself is just 2.0. Now, the reason for that is primarily simply because Curiosity suffered way too damage on its wheel. Now, you may be like, why the heck wheel is important? Well, wheel is important even though it's on a low gravity environment. Wheel still has rolling resistance. Basically, the RTG does not produce too much power, so the power gets trickle charged into the batteries. The battery provide the bulk power that is needed to drive these things. Now, the more damage these wheels sustain, the more energy it will consume just to move even 1 meter. So completely intact wheel, moving 1 meter, let's say, consumes let's say 200 watts. Just go with that, and let's say once the wheel is damaged, that will consume 250 watts. That simply means the battery will be degrading much faster because it has to endure much higher load, and energy for everything else, every other experiments will go down fundamentally. So that wheel is a critical thing. It must remain intact. So lessons were learned and new designs were basically implemented. So that's the one big thing. Like on a core structure level, this was one very big change. Then we have oxygen generator. Now that is also critical simply because this is also a very high energy drain equipment. So oxygen generator also needs to be tested. Now that is a very foundational level technology. Like basically we have to get this technology correct before we can even dream about colonizing Mars. Then caching soil sample for further missions. Now this is very far out thinking. How far out? Think of it this way: the best case scenario, like NASA is going YOLO on it, which they're always gonna delay it. Practically speaking, this is 2031. That's the best case scenario. So fundamentally that's a very far out mission. Then question is, why the heck they are doing it? They have to do it sooner or later. They have to do it. This mission was like, okay, might as well do it. It has a robotic arm, it has the ability to drill. Drill bit was changed to basically direct drill to like a hollow core drill, and that allows to extraction of material. That material, instead of having a different kind of lab which they had in Curiosity, that space is now dedicated to a different kind of packaging mechanism where it scans the material, categorizes it. If they find something interesting, they will try to study it with all the onboard equipments. If they find it is even more interesting than that, then they might decide to package it up. They have some capsules. They don't have only one capsule, they have multiple capsules, and they have the ability to tag it and mark it and drop it. So that will be done, and this is supposed to be there for multiple years, and then another rover will go there, pick it up. Then another launcher would be used to launch it to orbit, and then from orbit to Earth there would be another vehicle to be used. So it's a very far out plan. Then we have high risk high reward kind of scenario, basically Mars helicopter. Now this helicopter would become the first flying vehicle that actually tries to fly on anything other than Earth. So this is a very big deal. Then Curiosity rover, while terrain is bad, while you did improve the wheel, but there would not be any point of it if it suffers the same issue as Curiosity. Curiosity was getting stuck way too often, as in like not stuck as in like it can't do anything. It's just like it needs a constant help from Mother Earth. That is not acceptable. So fundamentally speaking, this time they are really banking on their new and improved algorithms, so it can drive upwards of 100 to 200 meters per day without needing too much assistance, which should allow, in principle, if done correctly and if it done over long years, as in like 2 years, 3 years, 5 years, and they only need like a human intervention 1 day or 2 days, it should speed up basically area coverage, that it should able to surpass Curiosity very quickly. So these are the core fundamental changes. Now let's talk about Jericho craters. Now Jericho crater is very interesting simply because this, as far as we know, was once flooded with water. Now when I'm talking about past tense, I do not talk about like a 10 years ago or 5 years ago. This is like millions of years ago. But as of now, with our best understanding of geology, we know it was water because lava has a different flow characteristic. Nothing else actually matches all the characteristics. So we know it was flooded with water. Now the interesting part is, utilizing other like high resolution satellite mapping, we know that there is a river delta. We can see the river delta. That's the interesting part here. Now we know for a fact, wherever we have river deltas, quote unquote, on Earth, they are very rich, they are very fertile in organic lives. Now I'm assuming that there was no super advanced alien civilization on Mars, and there was microbial life, which most likely there was. they would have lived into this sort of places. So this is the prime candidate if you want to figure out a microbial life in the past of Mars. Now, best analysis at this point in time is that lake bed and this whole air region should have, if there was ever life, this should have the fossil remains of that. So that's why they was wanted to land here. That is why it is so interesting, and that's why like sample return, because even if assume like they're utilizing all the onboard equipments they have, they find it and then they're like, dude, we have to do much further analysis. Then those basically samples that were cached, the secondary mission would be sped up, because if assume let's say they find something that's like, no, this is organic, I can guarantee you that second mission would be sped up insanely. So this is why the location was selected. Now, landing video. Now, that may not sound that scientifically important, but it is very, very critical, simply because this allows us to see the 7 minute of terror. Now, if you are very basically old enough, you would remember like older Martian rovers, because we did not get the context of size. We always see like, big air balloons going boing, 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 and done. Now, why don't we do that anymore? Simply because those rovers were tiny, as in this big. Yeah, they were tiny, so that can be done. But when you're talking about something that is size of a small car, as in like Tata Nano kind of size, Curiosity it was like the most largest they could manage to set it, like flat out. It was maxing out all the rocket, it was maxing out all the aeroshell designs, it was maxing it out. It was like, dude, we can't send anymore. Now this puppy does not go too much bigger in the size term, but it does go 100 kilogram heavier in weight size. So this puppy is like double maxed out. It's like, I cannot do any, like rockets are like, dude, we can't do much more than this. So we did that. Now, because of the weird size and the mass it has, we can't use parachute will not able to slow it down too much. Basically, it will slow down, undeniably so. It will go from, let's say, 1000 km/h to, let's say, 300 km/h, but you're still gonna crash this puppy at 300 km/h. Now you have airbags. Because of the mass and size of this puppy, the airbags would weigh as much as this thing. That simply is not acceptable. That's why I specified those early rovers were very tiny. That's why they were doable. With these things, is flat out not doable. Now you might like, why not have rockets directly bolted onto these things? That's awesome, but how the heck you gonna detach them? And if you don't detach them, that will end up acting as a drag on the mission. And if your mission is supposed to be for years long, you will be moving much slower, consuming most of your energy just trying to move the basically damn thing. And given the fact rocket engines have the tendency to go boom, especially if they are using hypergolic fluids, and they also have a tendency to corrode through the tank. So you can understand, like, you want something that has the power of rocket, but you want that to be as far away as possible. So best compromise was sky crane. Basically slow down as far as you can utilizing parachute, then use sky crane. Now this is the first time we saw a sky crane in action, and first time we saw, which is very important for future generation, rocket plume reacts on Mars. This is very critical. We theorized, we analyzed, we know that this works. I'm like, that's why Curiosity is on the surface, but we never have visual confirmation of that. Now you may be like, why do we need visual confirmation? Well, with visual confirmation, you can plan ahead. If you are planning to send, let's say, something as big as Starship, you need to know these data point. You need to know. That's like, oh, it landed good enough. That's not good enough for something that huge. And if you're familiar with Starship's boom events, you know for a fact that one of the engine went boom simply because one of the particles from the launch pad went inside the engine and went boom. So what will happen if that happened on Mars? You do not have a spare engine laying around. So fundamentally speaking, we need to know this. And you can see that like there are three primary cable that are like a weight cable, and there is a fourth cable which is the Ethernet cable that is connecting to the sky crane. Now, amazing part is, because the primary processing, memory, and transmission is done by the rover, the moment they detach, you can't see the sky crane's perspective, because it was programmed in such a way that the moment it detaches, it flies away as far as it can before it goes boom. Because if you try to run the engine to zero fuel, generally it has a tendency to going boom. So that's why we wanted something that we can detach and throw away. And because it's directly landing on its wheel, it's completely ready to go. It does not have to do unpack, unbolt, unhoo-ha. So that's why we have to utilize this 7 minute of terror. And this is the first time we saw the rocket plumes reacting. And the fact that they look invisible, that was like so mind-boggling. Think of this, like NASA has best engineers out there, and they are like, when they are doing the renderings and all the presentation is like giant engine plumes and all that. Now again, they know their stuff, so the plumes are like much more expanded, because it's like barely 1 psi in a Mars, like it's 0.1 psi. So they're like, yeah, the plumes will expand. That is happening, but we cannot see that. Even though it's a rocket engine plume, we can't see that. It was so mind-blowing. It looks like, what the hell is happening? So it was amazing. So I would urge you to watch that video, and I have provided the link down below. Now, this mission, many time you may find this like, what exactly are you doing? Like, why the heck curiosity is not good enough? Well, reality is it's not for that. It's not for scientific, as in like, whoa, are we gonna do this? It's more for testing the feasibility of Mars space. Because when lunar missions were done, as in like the Apollo mission, it was done on a war footing. Like, they would have gone to the moon even if it costed them lives, and it did costed them life. First three astronauts lost their life. So it was a thing, they had to do it no matter the cost. This time we can't do that. This time we can't be like, oh, we are sending people on Mars and they're gonna go poof. Yeah, that's not acceptable. We have to do it well, and we have to do it right in one go. On top of that, it has to be sustainable. Now that is the problematic aspect. If we want to do pick and come back, we can do that today. Like, if today people want to, like, okay, we want to go to Mars and come back, we can do that. We don't want that. We want to stay there as far as possible, as long as possible, lay the foundation on which, again, I'm not expecting like the first mission itself to be like, yeah, this outpost will be here 10 years from now, but lay the foundation on which we can do that. So that is why these sort of missions are being done, and NASA has like multiple mission plans ahead for that exact reason. Like, they have to build the foundation, and it's gonna be built brick by brick. Like oxygen generator, this golden box, this is very important. Like, you can bypass the methane generation stage by utilizing hydrogen, and hydrogen, while it's huge, it does have the luxury of being ludicrously light even in liquid stage. So as long as you have insulation good enough, you can store basically you can directly carry from low earth orbit to Mars enough hydrogen to have your return trip also. So that's doable. And if you can provide oxygen directly on the surface, you're good, you're golden. And you have to have oxygen because humans consume a lot of it. So this technology has to be tested. And there is another smaller payload, but it is also vital, is this plaque. This plaque contains material that NASA utilizes to make their astronaut spacesuit. Now, this is the first time these sort of material would be exposed to the Mars for multi-long year mission, simply because degradation is something that you have to learn the hard way. You can't test it out in a lab, you have to test it in real world. That's why like almost everything is like, Samsung Fold is like, yeah, in lab testing it works 100% of the time, but in real world it's like, yep, it broke. So NASA does not want that to happen. Like, think of it this way: everything is working fine. The mission is, everything is awesome, but like if a mission window is 2 years long, everything is working, and randomly people are like, oh, wait a minute, our suits are degrading, and after 6 months, like, they lost all the spacesuit because again the material itself was degrading. So they had to know this. That is why the small plaque is there. So you see that, like, look it from as a like building perspective point of view. You're like, okay, now we understand what NASA is doing. It's not planned for, oh, we're gonna learn more about NASA. Will we ever find sign of life on Mars? Hell no. I can guarantee you on that. Okay, I said this on 26 February 2021. Let's see how wrong I am in the future. But you get the point. Like, from a human point of view, this is what they're doing. They're building the foundation. So what we can expect in the future? Well, lot of data, this also has a ground penetrating radar, and if we are lucky, we may find a water source, like as in like a water source that we can directly drill into. So that would be really awesome if we are lucky. Even if we are not lucky, we will learn a lot about it. So lot more data about Mars, which will allow us to do much better planning and future system. Hope for flight. Now this will unlock everything, because right now this is like a gamble scenario, and even NASA classifies this as a high risk, high reward scenario. It's like, it works, awesome; it does not work, no big deal. But sooner or later we want to achieve flight on Mars, because once we can do that, we can cover a lot of things, so we can do amazing things. So we have to do that. Hope for oxygen. Well, again, we humans need oxygen, so it's not optional, it's compulsory. So these things are what we can learn from this Perseverance rover. So this was my presentation on basically Perseverance rovers. Hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please try to comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.